Section 3.6 is our last section for Chapter 3. So remember, that means tomorrow we review and on Friday we take a test. Okay, today we will prove theorems about perpendicular lines. First up is finding the distance between 2 points. It's been a while since we've done that. Does anyone remember how to find distance? Kara?
Isn't it b equals the square root, and underneath the square root it's like parentheses x2 minus x1 squared
Good.
plus y2 minus y1 squared.
Beautiful. This is our formula to find distance. It's been a while since we've seen it. But Kara is correct. This is how we set it up, so then we just have to plug our points in to be able to find our distance. So the distance would be, what are we plugging in for x2? Okay, 5 minus my x1, 2, that's getting squared, plus my y2, 7 minus 3, that gets squared. Okay, from here, we can kind of do a couple steps at once. What is 5 minus 2? 3, and when we square it, we get 9 plus, what is 7 minus 3? Square it. Add those together. 25. The square root of 25 is 5. So that one comes out nice. We have a distance of 5. All right, down at the bottom, I know the screen kind of covers it up with that logo, but the measure of angle DBC is 90 degrees, so that's the one on this side here in that corner. DBC is 90 degrees. What's the measure of angle ABD? So that's the one in this corner. It would also be 90 degrees because those form a linear pair. Okay, they're supplementary. They form a linear pair. Questions, concerns? Need more time on the warm-ups? Okay, we'll keep it moving. All right, the distance from a point to a line is the length of the perpendicular segment from the point to the line. So you can spell it out or you can put the symbol, but it needs to be the perpendicular segment. Okay, so here we are trying to find the distance from point A to line K, which is the one that's going left to right horizontally here. This is line K. So if we have to use the perpendicular segment to find that distance, which segment would that be? From the point to the line.
AC.
Which one?
AC.
AC is not perpendicular. That one's slanted. AB is what I heard somebody say. We got to start at this point and be perpendicular to that line. I tried to make it dashed, but I can make it a little more obvious. Okay, the perpendicular segment from the point to the line. So that, in this case, would be AB. Okay, we have to be specific about how we define distance from a point to a line. Otherwise, we could say, well, AC gets me from the point to the line, but that is a longer distance than AB. So we define distance as being the perpendicular segment from the point to the line. Questions about that? Okay. If two lines intersect to form a linear pair of congruent angles, then the lines are perpendicular. So in our diagram here, we've got angles 1 and 2. They are a linear pair. So if angles 1 and 2 are congruent, then what's true about G and H? G is perpendicular to H. Okay, because like we saw in the warm-up, if we know they're a linear pair and we know they're the same thing, they both have to equal what? 180 together, but separately they would each equal 90. And if they're 90, then we know those are right angles. We have perpendicular lines. Questions, concerns before we move on from this slide? Okay, we'll keep it moving. Next theorem. If two lines are perpendicular, then they form 4 right angles. Questions about this one? Okay, so if line A is perpendicular to line B, what do we know about all these angles? They're all right angles. So angles 1, 2, 3, and 4 are right angles. If they're all right angles, of course, we already know that they would all be congruent to each other. They all measure 90 degrees. Lots of other things that we can know from that information. I'm hearing lots of flipping, so I'm guessing we're ready to move on. Okay. First example. Angle 1 is congruent to angle 2. What can you conclude about lines A and B? Very good. Lines A and B are perpendicular. A is perpendicular to B. We know that because of the theorem that says if you have a linear pair of congruent angles, then the lines forming it are perpendicular. So if you want a reason, you could say linear pair of congruent angles. Okay, that's how we knew that those lines were going to be perpendicular. Pretty straightforward. Questions, concerns about it? Okay, we'll keep moving. Another theorem. If two sides of two adjacent acute angles are perpendicular, then the angles are, well, let's think about it. So, this diagram shows it to us. We know that we've got two adjacent acute angles. So, angle 1 and angle 2, they're next to each other, they're acute. And we know that the sides that are non-adjacent, BA and BC, are perpendicular because of that right angle box. So what do we know about those two angles? They're not congruent. It's another C word, though. Complementary. So they are complementary. I think I might have heard that being said, but I couldn't quite make it out. So if you have two adjacent acute angles, the sides are perpendicular, you know they have to be complementary. So if we know these are perpendicular, then we could just say angle 1 and angle 2 are complementary. We could say the measure of angle 1 plus the measure of angle 2 is equal to 90. Angle 1 and angle 2 are complementary. Okay, there are a few things that we know from that. One thing that we don't know, even if it looks that way in this particular picture, is that we don't know that those angles are congruent. Questions, concerns, need more time? Silence. Okay. Our favorite thing in the whole wide world, coming back for a visit. I don't hear any cheers. Yay, proof. All right. We are told that angles 1 and 2 are congruent. So, if we're writing a proof, that's where we should begin. First statement, angle 1 congruent to angle 2. What's my reason? It's given. Wonderful. Okay, so now I have to think about what I know because of that. Now, we could get really picky and add in lots of steps. Like, what else do we know about angles 1 and 2 other than the fact that they're congruent? They're a linear pair, so it's possible you could see that as a step. Angle 1 and angle 2 are a linear pair. Does anybody know what our reason would be? We can assume that from the diagram. That is something we can assume from a diagram, is having a linear pair. I think, Detriana, maybe you were telling me what should come next.
I said Q and V all perpendicular.
So you're talking about the two lines being perpendicular? I would agree, but we need to name them a little bit better. So we need to talk about two lines that are perpendicular, but in this case they didn't give us the little letters. So how many points do I need to name a line? 2. So what's one of my lines? Okay, you could call that QP is perpendicular to line SP, PS, something like that. If you were to call this QV, that would also be okay. Okay, and what would our reason for this be? Good. We had a linear pair of congruent angles. That was one of our theorems that we just filled in. If you have a linear pair of congruent angles, then those lines are perpendicular. Okay, so we're getting close, making progress. There's one other step we could throw in here about angles 3 and 4 before we do our prove statement. I don't know that I would necessarily require it, but what could we say about angles 3 and 4 right now? They're not congruent. We don't need to name them. They would. We know that from the lines being perpendicular if we were to add them up. But we're like going past proving it at this point. So imagine that we don't know anything about perpendicular or anything. Just go real basic. What's true about angles 3 and 4? If they're next to each other, they share a vertex and a line, then they are called any angles that would share a common vertex and a common side. They're adjacent. So we could say that angles 3 and 4 are adjacent. I'm not saying I would require that step, but if you see it in a proof where you're filling in the blanks, I want you to have seen it before. This is something else that our reason would be what? Assume from the diagram. We can see in the diagram that they are adjacent. Okay, and if they are adjacent acute angles formed by, and you've got perpendicular lines, what do we know about them? Sure, but if we're going to phrase it the same way the proof statement phrases it, we would say angle 3 and angle 4 are complementary. wrote that small. Okay, and then our reason for that, we would kind of have to restate that theorem from above. So I would say something like sides of adjacent acute angles are perpendicular. Unfortunately, we don't have names for these theorems, so we just have to kind of sum them up when we use them. Questions, concerns? All right, full of theorems today. These ones do have their own names. The perpendicular transversal theorem. If a transversal is perpendicular to one of two parallel lines, then it is perpendicular to the other. Okay, so for example, if we know that lines B and C are parallel, they put those little triangles on them for us, and we know that A is perpendicular to B, then what else do we know about line A? It's also perpendicular to C. Okay, lines perpendicular to a transversal theorem kind of takes that and goes the other way. In a plane, if two lines are perpendicular to the same line, then they are parallel to each other. So if line A is perpendicular to line C and line B is perpendicular to line C, what do we know about lines A and B? That they are parallel. A is parallel to B. All right, we are using this diagram to answer these questions. We do need to explain our reasons for our answers. So first up is line C, I'm going to highlight it for the sake of this problem, parallel to line D. Yes, how do we know? Both of them are perpendicular to what? Line A, right? You see the right angle boxes on A. We don't have a right angle box between D and B, so I would say both perpendicular to A. Questions about that reasoning? Okay. Next up is line B, perpendicular to line D. I think it is yes, but we have to have a reason for it. C is parallel to D, and C is also what to B? Perpendicular. So I would say yes because D is parallel to C and C is perpendicular to B. So that means that D would also have to be perpendicular to B. Does that make sense? Questions, concerns about it? If after we had shown or proven or said that C is parallel to D, you could have put the triangles on it if that helps you remember that those are definitely going to be parallel. Questions, concerns, anything else? Ready to move on to the next one? Some people are saying yes. All right, what is the approximate distance between line M and line, excuse me, N. So we've got these lines graphed for us. We know that if we are going to put a segment in to calculate distance, that segment needs to form what kind of angles? Like, for example, I'm not going to connect these 2 points to find my distance because this red line is not what? Begins with a P. Other P. Perpendicular. Remember, to find distance, that was one of the first things we talked about in these notes. Our distance has to be perpendicular. So I am going to want to use points that they give me, but I need to make sure that my segment that I'm forming is a perpendicular segment. So in this case, I think I should be connecting these points that are kind of in the middle here. Do we see that? That seems to form a right angle. Are we all okay with why I'm using those 2 points? Okay. So I like the right angle that forms here. So if that's the case, I need to know the coordinates of those 2 points so that I can find distance. So my left point, what are the coordinates of it? -2, 3, and my other point? 1, 2. Are we all okay with the coordinates there? Okay, then we can use our distance formula that we used in our warm-ups to find the distance between those points. First, I need x2. What is it? 1 minus my x1. So I would be subtracting what? Subtracting a negative is the same as adding. Square that plus my y2. 2 minus 3. Good. That gets squared as well. Questions about plugging in? You got to take x minus x and then y minus y. Kind of switching gears from finding slope, where we do the y's first and then the x's. Okay. Let's start simplifying. 1 plus 2 is?
3.
Square it.
9.
Plus 2 minus 3?
-1.
-1. Square it
1.
is +1. When we add them, we get the square root of 10. It said approximate, so if you were to plug this into a calculator and put square root of 10, did anybody get what it approximately comes out to? 3.16? Approximately 3.16. They didn't give us units, so I'm not worried about putting them there. Now, if we were to look at our diagram from the beginning, it should make sense that it's about 3, because if we start at this point and we count boxes over, it's a little more than 3. Right. Now, granted, this is not a right angle, so it's not perfect, but we can get a general idea of whether our answer is reasonable or not. For example, if your distance came out to be something like 10 units, clearly these are not 10 boxes apart, right? So you can use the diagram to help you see if your answer is reasonable. Questions, concerns? Warm, fuzzy feelings? Cold, prickly feelings? Void of all emotion? That's what it sounds like right now. All right. Our homework is on page 194. Again, this would be on your assignment guide, but if you need to copy it down here, that's fine. Tomorrow, we will have a review activity and a review guide worksheet for you to take. And on Friday, we will have a test.